The Pythagorean theorem can also be used to find the distance between two coordinates on a coordinate plane that are at a diagonal rather than exactly on the grid lines. So in this example, we can see that sometimes finding the distance between points on a coordinate plane is as simple as looking and counting the number of units. So in this case, we know that the distance between these 2 points is 6 units because it's exactly 6 blocks from the coordinate 1, 3 to the coordinate 7, 3. Sometimes it's trickier and we have to use a mathematical approach because we can't just count the boxes. If they're at a diagonal, I don't want you counting the boxes like that. You can't do that. You won't be exact. So we're going to learn a way where we can figure out exactly what the distance is from here to here using math, using right triangles. So this says other times we might need to find the diagonal distance by creating our own right triangle and using the Pythagorean theorem to calculate it. So like normal, we have some steps to follow. So our first step, so this says steps for finding the distance on a coordinate plane by using the Pythagorean theorem. I know the Pythagorean theorem is a way of working with right triangles to find distances, unknown distances of one of the sides of a right triangle. So my first step here is going to be to plot the coordinates they give us and connect those dots. So example 1, we're plotting the coordinates and connecting them. So my first coordinate, remember coordinates are written as x, comma, y. X is our side to side distance, y is our up and down distance. So I go over to 4 and then up to 3 for my first coordinate. My next coordinate is 0, -2. So my left to right distance is 0, and then I go down to -2. Now I'm going to use a straight edge. You can always just fold a piece of paper in half if you don't have a ruler. And I'm going to connect those dots. My second step is to stay on the grid lines and draw a horizontal and vertical line to make a right triangle. So this is like what we did when we did slope. So what we're going to do is I'm not going to just draw random lines. I need to follow the grid lines. So see how I say exactly on the squares? And I have a right triangle drawn. Then I need to label the hypotenuse C and the other sides A and B. So remember our hypotenuse is the longest side, which is also our side that is exactly diagonal from our right angle. So this is C. That is the side we're looking for. I'm going to label this one A and then this one B. Count the length of sides A and B. So A is pretty easy to find. We're just going to count and we have 4 units. B, we're just going to count as well and we have 5 units. C, I can't count because it's diagonal, so we're going to solve for it. So we're going to write out the Pythagorean theorem and plug in for A and B. The Pythagorean theorem is a squared plus b squared equals c squared. Remember, I like to do my parentheses so I make sure I don't forget any parts when I am substituting out for certain numbers. A is 4, B is 5, C is unknown, so I'm just going to keep the letter C. 4 squared is 16. 5 squared is 25. C squared. I can add 16 plus 25 and get 41. 41 equals c squared. I'm not done. My last step is to solve for c. So I've almost solved for c. Right now I'm solved for c squared. To get rid of that little 2, we have to take the square root of both sides, and the square root of 41 is 6.4. So the length, the distance between the coordinates 4, 3, and 0, -2 is 6.4. And we can use this little squiggle for approximately, which just means that's about that much because we had to round, because this is an irrational number. Let's do the other 2 examples. So we're following the exact same steps again. My first step is to plot the coordinates and connect them. Make sure I plot them in the correct location. This first coordinate is -4, 3. And the second coordinate is -2, -4. I'm going to connect my dots. And then I'm done with the first step. The second step is to stay on the grid lines and draw a horizontal and vertical line to make a right triangle. So what I need to do is draw a horizontal line and a vertical line in order to connect these dots. If you were to draw the line here to here, it wouldn't change anything. You will still get the correct answer. So I have my right triangle drawn, and I'm going to go on to step number 3. Step 3 says to label the hypotenuse C, which is the side directly across from our right angle. That is C. That is going to be the side we're solving for, because that is what was directly connecting our dots. The other 2 sides are A and B. My fourth step is to count A and to count B. My fifth step is to write the Pythagorean theorem. A squared plus B squared equals C squared. We're going to leave our blanks before we plug in the numbers to ensure we don't forget anything. I know that A is 2. I'm going to write this in another color so we can see it. B is 7. And C is our unknown, because I can't just count those squares. I know that 2 squared is 4. 7 squared is 49. And we don't know what C squared is, so I just have to write C squared. I can add 4 plus 49 together, and I get 53. And then my last step, because right now we have C squared, we don't want C squared, we want C by itself. So I take the square root of both sides. 53 is not a perfect square, so we're going to have an irrational number. And so we will round to the nearest tenth and get 7.3. We'll do one more, but I'll go through this one a little bit more quickly. My recommendation would be to pause the video here and try it on your own before continuing. We're doing all the same steps. So my first step is to plot these coordinates at 3, 4, and -5, -4. and connect the dots. My next step is to stay on the grid lines and draw a horizontal and vertical line. I have my horizontal line. I have my vertical line. Oops, I went a little too far. Then I need to label the hypotenuse C. So I have my right angle that formed when I had my horizontal and my vertical line. The one diagonal from my right angle is my hypotenuse, which is C. And then the other sides, doesn't matter which one's which, are A and B. I'm going to count the length of A and the length of B. And then I don't know the length of C. I'm going to write out the Pythagorean theorem, which is a squared plus b squared equals c squared. I write it out to have my blanks for each letter. Like I did before in the last problem, I'm going to just use this color. A is 8, B is also 8, C is unknown, so we're leaving it as the letter C. 8 squared is 64, plus 8 squared, 64, equals C squared. 64 plus 64 is 128. And then my last step is we want C, we don't want C squared. So I need to take the square root to get rid of the squared. And I get the square root of 128, which is approximately 11.3. So our approximate length of C is 11.3, the distance between those coordinates.